What is aggregate?
Well, aggregate is one of the three principal ingredients of concrete. It comes in different sizes and starting from sand and moving up to larger particles. And these particles fit together to produce a dense material. So in concrete, these pieces of aggregate are bound together by a mixture of cement and water to produce a material that is initially moldable and with time develops strength and becomes stiff.
What is cement?
Well, cement is the second principal ingredient of concrete. There are many types of cement. The one we use most widely is called ordinary Portland cement. The way that's made is to take 3 portions of limestone and 1 of clay, heat them to 1500 degrees centigrade in a kiln, grind that material down to a powder, the powder that we call cement. So if we take cement and mix it with water, we form a paste. And within the paste, chemical reactions occur. We call those hydration. And those result in the paste turning from a liquid into a solid material.
So what's the point of the aggregate?
That's a good question. The cement paste acts as a glue to hold the particles of aggregate together. Aggregate's just as strong as cement paste and is far less expensive, and so we use concrete rather than cement paste on its own. There are other reasons too why we don't use cement paste in construction. Cement paste expands and contracts as it heats and cools. It also expands and contracts as it wets and dries. The aggregate, which is more stable, reduces these effects.
Does the manufacture of concrete have a high carbon footprint?
Yes, it does. Cement manufacture involves heating the raw materials to a temperature of 1500 degrees C, which uses a lot of energy. Also, as the limestone is broken down in that process, it releases carbon dioxide, leaving calcium oxide. And that CO2 goes into the atmosphere and contributes to the carbon footprint of cement. But actually, that isn't the whole story. Concrete is a very energy efficient material when used in buildings, in the sense that it will store energy in the winter, and it will keep buildings cool in the summer. And so when viewed across the whole life of a building, concrete compares very favourably with other materials. But there are situations where energy efficiency is not of concern. And examples of that are foundations for buildings and the walls of a dam. But in those cases, alternative materials don't exist.